Good day everyone, you are welcome to Easydone Tutorial Academy. Today we'll be looking at physics and then measurement. We're talking about measurement. We will be looking at quantities. And we have two types of quantities in physics we use to measure. We have fundamental quantities, and then we have derived quantities. So when we say fundamental quantities, we mean that these are the quantities that they are independent. So what are the fundamental quantities? Fundamental quantities, what are they? They are the what? Length, time, mass, temperature, luminous intensity, and then electric current. And each of them, as they also have, when you say quantity, they have their units. So what is the unit of length? Unit of length is what? Meter. M. Unit of time is what? Seconds. S. Unit of mass is what? Kilogram. Kg. Unit of temperature is what? Kelvin. K. Unit of luminous intensity is what? Candela. C. Unit of electric current is what? Ampere. A. These are the fundamental quantity and these are the fundamental unit. These you are seeing, they are the ones that we use in derived other quantity, and that is why the second one is called derived quantity. So this derived quantity, they are the quantity that depends on the fundamental quantities. Without them, you cannot get a derived quantity. What are derived quantity? For instance, we have what? Area. So what is area? Area is what? Length times breadth. What is the unit of length? Meter. What is the unit of breadth? It's also meter, which is what? Meter square. Also, volume is one of derived quantity, which is length times breadth times height. Because there is no way you can say you want to use the quantity for breadth and height. Therefore, we make use of what? Length for both of them. Therefore, we have length times length, which is meter. That's how you have meter cube. So the unit of volume is what? Meter cube. Another derived quantity that we have is what? Density. What is the formula for density? Density is what? Mass over volume. So what is the unit of mass? Kg. What is the unit of volume? Meter cube. That means the unit for density is kilogram per meter cube. Another derived quantity is what? Force. What is the formula for force? Force is equals to mass times acceleration. So, what is the unit of mass? Kg. What is the unit of acceleration? Meter per second square. That means the unit of force is meter per second square or Newton. So you have to read more on the derived quantity, in which we are going to be using these to get to derive the unit for them, which means the derived quantity depend on fundamental quantity. So because of this, there are something we call dimension in physics. Dimension. So therefore, there is a way for you to know this dimension very well. In physics, when you are being given dimension, all what you are being expected to do is just make sure you leave your answer in length. Dimension in physics we have is length, mass, and time. This is what they call dimension. So when you are being asked to find the dimension of something, especially derived quantity, they cannot ask you to find the dimension for, let's say, length now, or mass, or electric current. No. You'll be asked to find the dimension of force. So how do you find the dimension of force? All what you need is just know the formula for force. What is the formula for force? Mass times acceleration. So mass is one of the dimension, that means m is there, times acceleration is not in the dimension. Therefore, what is the formula for acceleration? Acceleration is what? Change in velocity over time, which means that you can turn this one to be m times v t raised power minus 1. Also, your v is not dimension. Therefore, break your v down. So you are going to be having m t raised power minus 1. What is v? Change the displacement over time, which is what? Distance all over time. But remember, there is nothing you can use to replace distance in dimension, which is what? Length. Therefore, I'm going to be having m t raised power minus 1 l t raised power minus 1. Since you are having the 2t, you can put them together. So the dimension for what? Force will be m l t raised power minus 2. This will be your final answer. Therefore, when you are being asked to find the dimension for density now, I believe you know what to do now. Dimension for what? Density. What will be your question? What is the formula for density? Mass over volume. Of course, so what is the dimension of mass? M is m. Dimension of volume is what? Length raised power 3. That means dimension for density is equals to what? M L raised power minus 3. That is it. Also, what is the dimension for velocity now? I believe you'll be able to do this now. Velocity is what? Change the displacement over time, which is what? You can say L all over what? T, which will give you what? LT raised power minus 1. That is the dimension for velocity. What is the dimension for acceleration? Acceleration will give us what? Change in velocity over time. Now that you've already known the dimension for velocity, that means your velocity will be L t raised power minus 1 all over t. Isn't it? We should now give you what? L t raised power minus 1 t raised power minus 1, which will give you LT raised power minus 2. So, let me give you what to work on. Assuming you are asked to find the dimension of speed. Dimension for speed. What is the formula for speed? Yes, of course, you have to remember speed is what? Distance over time. Distance all over time. Since we have said that all what we need for dimension is length, time, and mass. What can we use to represent distance? L all over t, which equals to what? LT raised power minus 1. You will discover that speed and velocity have the same dimension, and that is why both speed and velocity is used interchangeably in physics. So therefore, don't forget, when you are being given any questions on dimension, all what you need is to be your answer in length, time, and mass. So with these three, you'll be able to get the question you are being given. So quickly, let's look at dimension for momentum, and that is where I'm going to stop for dimension. Momentum. Some candidates used to mix momentum for moment. There's a difference between momentum and moment. Moment is different from momentum. What is the formula for momentum? Say momentum is mass times velocity. That's formula for momentum. Mass times velocity. Mass times velocity. Okay, what's our mass? M. And what's our velocity? L t raised power minus 1. Then that means what do we have answer? M L t raised power minus 1. So can you just say that for when you are being given a questions now, you don't need to make that mistake. Just make sure you look at the question being given to you, then find a way of solving it or reducing it in terms of LTM or MLT or TLM. Any of these three is what we call dimension. Don't forget to subscribe, comment, like, and share. Thank you.